Hi students, welcome back. In the last classes, we were discussing about dimensions. We have studied about how to find dimension of different physical quantities, right? I hope you are clear with that topic, how to find a dimension of different physical quantities. Before going into the details of today's topic, first let us find dimension of a quantity. Here, let us find dimension of torque. Torque is one of the derived quantity, and now let us find dimension of torque. And we know to find dimension of a quantity, first of all we should write the equation, right? So torque is equal to, its equation is force into perpendicular distance. Perpendicular distance is torque, and torque is represented by the symbol τ. This is the symbol τ which represents torque. So torque τ is equal to force into perpendicular distance. Perpendicular distance means it's a distance, so it is F into D. So dimension of torque is equal to dimension of force into dimension of distance. And we have already studied about the dimension of force. Dimension of force is equal to, what is the equation for force? F is equal to ma, mass into acceleration, and dimension of mass is capital M, dimension of acceleration is Lt raised to minus 2. So dimension of force is equal to ml t raised to minus 2. ml t raised to minus 2 into distance. Distance means it's a length, so its dimension is L. So dimension of torque is equal to m, L into L is L square t raised to minus 2. This is how we find dimension of torque. In order to find the dimension, we should know the equation, and from that equation we can find the dimension of any physical quantity. Okay, then today we are going to discuss about how we apply this dimension, that is applications of dimensional analysis. Today we are going to study about the applications of the dimensional analysis. Let's see what are the applications. Actually there are 3 applications, and let us study about the first application today, that is to check the consistency of physical equations. So this is the first application, to check the consistency of equations. I will tell you what you understand by this consistency of equations. In physics we have different equations. We are available with different equations, and in order to check whether these equations are correct or not, we can use this dimensional analysis. And here, in order to check the consistency or the correctness of the equation, actually we are using a principle known as homogeneity principle. Principle of homogeneity is used. Principle of homogeneity is used in order to check the consistency of equation. Let us discuss what do you understand by this principle of homogeneity. I will tell you what is the statement of this principle. According to this principle, a physical equation will be dimensionally correct if the dimensions of all the terms occurring on both sides of the equation are the same. This is the statement, and I will tell you about the statement in detail. For that, let us consider one equation. Actually, it is used to check the correctness of the equation, And let us consider one equation. V is equal to u plus at. You have already studied about this equation. And we are using this equation. And here in this equation, what is V? V means it is final velocity, u represents initial velocity, a is acceleration and t is time. And we can use this principle of homogeneity to check correctness of this equation. And if this equation is correct, then here in this equation we can see that on both sides there are three terms involved in this equation. One is v, second term is u, and the third term is a into t. These are the three terms involved in this equation. And if this equation is correct, then the dimension of all the terms occurring on both sides of this equation are the same. That is, dimension of v is equal to dimension of u, that must be equal to dimension of at. Then if all the terms are having the same dimension, then we can say that this equation is a correct equation. This principle is known as principle of homogeneity. So let us check whether this equation is correct or not. For that, first let us consider this term v. According to this principle, dimension of v must be equal to dimension of u and dimension of at. Then only this equation can be considered as a correct equation. Dimension of v. What is dimension of v? Dimension of v is L t raised to minus 1. That is, v means velocity. Velocity is equal to displacement by time. Right? Displacement is a length and its dimension is L. Time dimension is t. So that is equal to L t raised to minus 1. L t raised to minus 1. Then on the right hand side of this equation, the terms are u and at. So let us take the second term u. U means it is again velocity, but it is initial velocity. So what will be its dimension? It will be the dimension of u will be same as that of v, because both are velocities. So we can write dimension of u as lt raised to minus 1. So these are having the same dimension. Then let us take the third term. What is the third term? Third term is a into t. So a. Let us write the dimension of this term at. Dimension of a is, what is dimension of a? Lt raised to minus 2. It is acceleration. Acceleration's dimension is given by Lt raised to minus 2. Then t. T is time. It is a into t. We have written only dimension of a and it is at. So dimension of t must also be written here. So dimension of t is what? T. So dimension of at is equal to L t raised to minus 2 into t raised to 1 is t raised to minus 1. So dimension of at is also equivalent to L t raised to minus 1. So see, all the terms involved in this equation are having the same dimension. What is the dimension? Lt raised to minus 1. So we can say that this equation is dimensionally correct. So it is based on this principle of homogeneity, we can check the correctness of the equation. If an equation is dimensionally correct, then the terms involved on both sides of the equation are having the same dimension. This is about the dimension, checking the correctness of the equation or the consistency of the equation. Let us take another example. S is equal to ut plus half at square. Let us check the consistency or the correctness of this equation. So as you can see, this equation has three terms. One is s, and second term is 80, and the third term is half 80 square. But half is a number, so we don't want to bother about this half. So to check the consistency of this equation, we have to write down the dimension of these three terms. First term is s. What is s? S is displacement, right? So what is the dimension of displacement? Displacement dimension is, what is the dimension? L. L is the dimension of displacement. Then second term is u into t. U into t, product of velocity and time. What is dimension of u? It is L, t raised to minus 1 into t. So into t means dimension is t. So what will happen? T raised to minus 1. This is t raised to 1. So what is that? L, t raised to 0. What is t raised to 0? A raised to 0 equal to 1. So t raised to 0 is also equal to 1. So this is equal to L. So dimension of ut is equal to L. Then last term is at square, right? At square, which is equal to a into time square. A is acceleration. Its dimension is lt raised to minus 2 into t square. Dimension is t square. Here also t raised to minus 2, t raised to 2, which is equal to L, t raised to 0, which is also equal to L. So check the dimension of all the three terms. L, s is having the dimension as L, ut, again L, and at square, again L itself. So we can say that this equation is dimensionally correct according to principle of homogeneity. This is how we check the correctness of the equation. This is the first application of dimensional analysis to check the consistency of equation or to check the correctness of the equation. Okay.